Have you ever wondered if we are alone in the universe? Such a question has captivated the human mind for centuries, sparking curiosity and kindling imaginations. The concept of extraterrestrial life, of beings beyond our small blue planet, is not only exciting, but also significant. It probes into our understanding of life itself, pushes the boundaries of what we deem possible, and challenges our place in the cosmic order. Are we the sole bearers of consciousness in a universe of silent stars? Or do we share this grand cosmic stage with others? This question is not just about aliens or the possibility of interstellar neighbors. At its core, it's about us, about our longing to understand and connect, about our innate desire to explore the unknown. As we delve into this mystery, let's begin by looking at the vastness of the universe. Our universe is unimaginably vast and old. Let's take a moment to try and fathom this. The universe has been around for approximately 13.8 billion years. That's a number so large, it's almost impossible for us to fully comprehend. Within this expansive universe, there are estimated to be around 2 trillion galaxies. Each of these galaxies, including our very own Milky Way, contains hundreds of billions of stars. Now, if we do the math, that's a whole lot of stars. But it doesn't stop there. Around these stars there are planets, potentially as many as 100 billion trillion planets in the observable universe, give or take a few trillion. That's a number so large it's almost incomprehensible. Now, let's talk about habitable zones, also known as Goldilocks zones. This is the area around a star where it's not too hot, not too cold, but just right for life as we know it to possibly exist. It's where water can exist in its liquid state, a crucial ingredient for life as we understand it. Our planet, Earth, is in the Sun's habitable zone, and we've discovered numerous other planets in the habitable zones of their respective stars. With so many stars and so many planets, the number of these Goldilocks zones is likely in the billions. To put it simply, the universe is a vast cosmic ocean filled with galaxies, stars, and planets. It's a place of unimaginable scale and potential. Given the vast quantity of stars and planets and the existence of habitable zones, it would seem statistically improbable that Earth is the only place where life has evolved. And so, we find ourselves pondering an intriguing question. With so many possibilities, can we really be the only life forms? In this vast cosmic ocean, are we truly alone? Or is there life waiting to be discovered amongst the stars? Life as we know it requires specific conditions, but what exactly does this mean? Let's break it down. First off, we need water. It's not just for quenching your thirst on a hot summer's day, but it's also the perfect medium for biochemical reactions. Basically, it's the ultimate mixer for life's cocktail. Then we have energy sources. Life is a constant struggle against entropy, and to keep going, organisms need to take in energy. On Earth, we see life harnessing energy from the sun through photosynthesis, or from chemical reactions, as in the case of deep-sea vent organisms. And let's not forget about certain chemical elements. Carbon, hydrogen, nitrogen, oxygen, phosphorus and sulfur, or trinops for short, make up about 99% of our body weight. These elements are the building blocks for proteins, DNA, and other key components of life. Now you might be thinking, sure, these conditions are met on Earth, but what about elsewhere? Well, that's the exciting part. We found evidence of these conditions on other planets and moons in our solar system. Take Mars, for example. We know that it once had liquid water on its surface. And there's Enceladus, a moon of Saturn, that has an ocean of liquid water beneath its icy surface. Even more intriguing, Jupiter's moon Europa also harbors a subsurface ocean that could contain more than twice the volume of all of Earth's oceans combined. In terms of energy sources, we've observed geothermal activity on moons like Io and Enceladus. And as for those crucial chemical elements, well, they're pretty common throughout the universe. So, what does all this mean? It means that the conditions necessary for life as we know it aren't unique to our little blue planet. These discoveries suggest that the conditions for life might be more common than we once thought. Scientists have been actively searching for signs of alien life. This search has taken many forms, each of them fascinating and filled with the promise of discovery. One of the key players in this quest is the search for extraterrestrial intelligence, or SETI. This project uses powerful radio telescopes to scan the cosmos, listening for signals that could indicate the existence of intelligent life beyond our planet. These signals could come in many forms, from deliberate broadcasts to unintentional leaks of radio or TV signals. The thought is, if we can broadcast, why not others? It's like tuning a cosmic radio, hoping to catch a whisper from the stars. But of course, it's not as simple as just tuning in and listening. There's a lot of cosmic noise out there, and distinguishing an alien signal from that is a task of astronomical proportions. Apart from signals, there's also the search for exoplanets, planets beyond our solar system. With advances in technology, we now have the ability to detect these distant worlds. We're not just looking for any planets, though. We're particularly interested in those that exist in the habitable zone of their stars, where conditions might be just right for life as we know it to exist. Then there's the study of these exoplanets' atmospheres. By examining the light that passes through an exoplanet's atmosphere, scientists can determine its composition. They're looking for certain gases that could indicate the presence of life. Oxygen, for instance, could suggest photosynthesizing organisms. While we have not found definitive proof of extraterrestrial life yet, these searches are expanding our understanding of the universe. Each new exoplanet discovered, each new signal analyzed, brings us one step closer to answering the question, are we alone in the universe? And even if we haven't found our cosmic neighbors yet, the journey of discovery, the expansion of our cosmic horizons, is in itself a testament to our species' unquenchable thirst for knowledge. The Drake equation is a tool used to estimate the number of advanced civilizations in our galaxy. It's like a cosmic roll call, a mathematical formula that takes into account several factors. First, it considers the rate of star formation in our galaxy because, as we know, stars are the cradles of planetary systems. Then it looks at the fraction of those stars that have planets. Not every star has a planetary family, but those that do increase the odds of finding life elsewhere. Next, the equation factors in the number of planets that could potentially support life. These are the so-called Goldilocks planets, not too hot, not too cold, and with conditions just right for life as we understand it. The Drake equation doesn't give us a definite answer, but it does provide a framework for our thinking. And even when we plug in conservative estimates into this equation, the possibility of alien life seems likely. The Fermi Paradox asks, if there are so many potential civilizations, why haven't we encountered any? It's a mind-boggling question that has puzzled scientists and philosophers alike. One possible explanation is that we might not be listening properly. Our methods of communication are primarily based on our own understanding of technology, which could be vastly different from an extraterrestrial civilization's technology. Could it be possible that they're trying to reach us, but we're just not picking up their signals? Another disconcerting theory is the self-destruction of civilizations. This notion suggests that advanced societies might have a tendency to destroy themselves before reaching a stage where they can make contact with others. Whether it's through warfare, environmental destruction, or some other catastrophe, these civilizations might be victims of their own progress. The Fermi Paradox reminds us that the question of alien life is still full of unknowns. And while we might not have the answers yet, the search for extraterrestrial life continues to ignite our curiosity and drive our scientific endeavors. We may not have definitive proof of extraterrestrial life, but the possibility is tantalizing. We've traversed the vast expanse of the universe, shining a light on its awe-inspiring enormity. We've delved deep into the ingredients necessary for life, realizing that they are not as unique to our planet as we once believed. Our relentless search for extraterrestrial life has led us to probe distant planets and galaxies in hope of encountering signs of existence beyond our world. We've grappled with the Drake equation, a mathematical formula that suggests the probability of intelligent life existing elsewhere in the universe is more than a fantasy. Yet, the Fermi Paradox has left us perplexed, questioning why, if there is a high probability of extraterrestrial life, we haven't made contact yet. Despite these complexities, our quest for understanding continues. As we continue to explore the universe, we may one day find the answer to the question, are we alone?